All right, so today we're going to be starting our new unit, which is solving systems of equations. A system of equations is just two or more equations with the same variables. So they're going to be two equations that have the same variables. We're going to solve them at the same time. As you guys advance into more difficult math, you'll have three equations, three variables. We're going to stick to just solving two equations at the same time. They'll have the same two variables. Those variables, for the most part, will be x and y. A solution to the system of equations, when we're graphing, which is what we're doing today, that is going to be the point where the two lines intersect. So where the two lines cross, that is the solution. And algebraically, which we'll work on tomorrow and then next week, it is the point xy that makes both equations true. So in an equation, the points that are on the line are the coordinates that make that equation true. So we plug in the x value, we plug in the y value, and it makes the equation true. In a system, it has to make both true at the same time. There are three different types of solutions for when we are dealing with systems of equations. When we have two lines that intersect, that intersection point is the solution. So for these two lines right here would be our solution. It's where those two lines intersect. If we have parallel lines, they will never intersect, and so that will have no solution. And if the equation ends up being the same equation, so I have one line, and then the other equation is the exact same line, that means that there are infinite solutions. Every point on one line makes both equations true. What we're going to work on today is we're going to work on solving systems by graphing. So the way we're going to do that is first, we're going to make sure that we rewrite both equations in slope-intercept. So y equals mx plus b. Then we are going to graph both lines. And then our last step, we'll find the point of intersection. So basically today we're just graphing two lines at the same time, seeing where those two lines cross. So just getting into a couple examples for these first two, both of our equations are already in slope-intercept form. So for our first line here, -8 is where we're going to start. So we go down to 8, 1, 2, 3, 4, 5, 6, 7, 8. And then our slope is 1. Right, so from that -8, we'll go up 1 over 1 to make a couple more points. And then we just draw a line that goes through our points. So there's our first line. And then we're going to do the same thing with this next one. So we'll start up at we'll start up at 1, put our first point, and then our slope is -2. So from there down 2, right 1. Down 2, right 1. And then we connect those dots. The more dots you draw, the more accurate your lines will be, and it'll be easier to see where our lines cross, if they cross. And so here we have our solution. It's right here where those two lines intersect. So that is over at 1, 2, 3, and then down 1, 2, 3, 4, 5. So our solution for this equation, or this system of equations, is 3, -5. All right, remember what a system does is, or what the solution shows is it shows where those two lines intersect. It shows the point that makes both equations true. So for this first equation, if I plug in negative 5 for my y, and then 3 for my x. Negative 5 equals 3 minus 8. 3 minus 8 is negative 5, so that's true. And then if I plug it into our second equation, negative 5 for y, and then 3 for x, negative 2 times 3 is negative 6, plus 1. That equation is also true. That is the only point that if I plug in those two numbers will make both equations true. All right, we're going to look at this second one, same idea. So for my first equation, starting up at 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my slope is 1/2, so up 1 over 2. Or I could go down 1 and then left 2. Remember, the more points we draw, the more accurate our line will be, the easier it'll be to see where these lines intersect. All right, and then we're going to do the same thing with the second equation. So starting up at 6, 1, 2, 3, 4, 5, 6. Now my slope is negative 1, so down 1, right 1. Get a couple of points, connect them, and then the point where they intersect is our solution, and that's going to be right here. All right, so that is at the point negative 2, and then up 1, 2, 3, 4, 5, 6, 7, 8. So negative 2, 8 is our solution for that system. All right, and then on this next page, we have equations where some are in standard form, some are already in point or slope-intercept form. But for the ones in standard form, we have to rewrite them. So for this first equation on number 3, we have to get rid of that 3x on both sides, so we're just going to add it to both sides. And then since there is nothing in front of the y, we don't have to worry about the division step. So we just add the 3x to both sides. That equation is now y equals 3x plus 8, and we're ready to graph. So we're going to start by going up to 8. And then our slope is 3. I don't have enough space to go up and right, so instead we're going to go down 3 and then left. Remember, we want our slope to be positive, so it has to go up as it's going to the right. And then we're just going to connect our dots. We're going to do the same thing with the second equation, so I need to get rid of that minus x. We're going to do that by adding x to both sides. And then again, our equation is rewritten and it's ready to go. We have y equals x minus 2. So we'll start by going down to negative 2, put our point, and then my slope is positive 1, so up 1, right 1. Get a couple of points, put a line through them, and then we'll have our solution. The more points we draw, the more accurate our graph will be. And so right here is where those two lines intersect. All right, same with the next one. So we have to start by getting rid of the x. Since it's positive, we're going to subtract that from both sides. So then our new equation is 2y equals negative 1x plus 4. And then our last step is going to be to divide everything, all three of the numbers, by 2. I always put the 1 because then I can see that my slope is a fraction. And so now we have our new equation. We have y equals negative 1/2 x plus 2. So start by going up to 2, put a point, and then my slope is negative 1/2, so from there down 1 over 2. All right, remember, more dots we can draw, more accurate it'll be. We can do the same thing going the other direction, so up 1 and then left. And then we connect our dots. My second equation is already in slope-intercept form. It's negative 1/2 x plus 2. And so if I go to graph that one, I go up to 2, put my dot. My slope is negative 1/2, so down 1, right 2, and it ends up being the same line. And so what that means is that this system has infinite solutions. All right, they're the same line. They intersect at every point. If they were parallel, it would have no solution. All right, so looking at these last two really quickly. Number 5, I have to rewrite the first equation. So start by subtracting x from both sides. Now we have 3y equals negative 1x minus 15. And then again, we're going to divide everything by 3. So now my equation becomes y equals negative 1/3 x minus 5. And we're ready to graph. Go down to 5, 3, 4, 5, put our dot, and then negative 1/3, so down 1 over 3. And then we put our line through those points. For the second equation, because we just have y equals negative 7, we're going to go down to 7, and then that line is just going to have a 0 slope. It goes straight left and right. And so we can see where we intersect right here at 6, negative 7. And then for the last one, first equation's ready to go. So I'm going to go up 5, put my dot. My slope is 1, so up 1 over 1, and draw our line through those points. And then for the second equation, we are going to rewrite it. So right now we have x minus y equals 2. We're going to start by subtracting x from both sides. Now I have negative y equals negative x plus 2. And then when we divide by negative 1, we get y equals x minus 2. So when we go to graph this, we go down 2. And then again, my slope is 1. So that means that these two lines are parallel. They will never intersect. And since our solution is where they intersect, that means that for this problem, we have no solution. So that is how we are going to solve systems using graphs today.